Okay, so last time we looked at substitution. Remember, substitution was the process. We had two equations, both having x and y, similar to what we have in example 1 here. Remember, when I have an equation with x and y both, I can't really solve for anything. I can't have x equals a number. Well, I can't solve and get like a final answer. I can't get x equals a number or y equals a number if there are both x and y in my equation. So the way we fixed that problem last time was we knew what x was, an expression to substitute in for x or y. We substituted it in to form just an equation with just x or just y. Right? So we were taking two equations with x and y both, and we were kind of using a process of substituting an expression in for one of those variables to make a single equation with just x or just y. That was substitution. Give me a wild guess. What do you think we're going to do with the elimination method? We're going to eliminate either x or y. Okay? So before we substituted an expression in so that we just had x or y, now we are going to simply eliminate x or eliminate y. All right? So that's the process that we're going to do today. We're going to do the most basic type today. We'll get into some that are a little bit more challenging next class, but hopefully today will be simple enough, okay? So that being said, I want you to have a quick conversation with your partners about, and I'll give you like 15 seconds. Give me numbers that would eliminate each other if we added them together. So give me talk to your partners about pairs of numbers that when you add them together would eliminate each other. Go ahead. Good. What kind of pairs did you guys come up with? Yeah, Max.
Like if it was a 6 minus a positive 6, like a negative 6.
So 6 and negative 6. What else? 2 and negative 2. 10 and negative 10, right? Lots of different pairs. Okay, now I'm going to make it a little more challenging. I'm going to stretch you a little bit. Now I would like you to talk with your partners about pairs of variables that would eliminate themselves if you added them together. Go ahead.
I was going to say that. X and negative x and y and negative y.
Oh, so can you say that again?
You're looking for pairs of variables that would eliminate each other when you add them.
1A, 2.
We're not done yet until we finish.
I think. Would that
Negative
no?
10x and 10x.
Because if you add like two numbers with variables, you just
Are you on the notes?
So it would be negative b.
Okay, what did we come up with for pairs of variables that would eliminate each other? Yep, Ethan.
1x and negative x, I guess.
Okay, so x and negative x, those would eliminate each other. What else? Yep.
1y and 1 negative y.
Okay, so y and negative y. Somebody expand it a little bit for me. Yeah, Chris?
Negative 10x and 10x.
Good, 10x and negative 10x. Okay, so essentially what we are looking for are opposites, right? We want some kind of opposites that will eliminate each other. Do you see on example 1 any opposites that would eliminate each other? What do you see, Alex?
The negative 6y and 6y.
Negative 6y and 6y. If I added negative 6y plus 6y, what would I get?
0.
0, right? Not y. Don't fall into that trap. If I have 6 apples and I eat 6 apples, I don't have an apple left. I have nothing left, right? All right. Except some cores, but that's beside the point. Sorry. Passes distract me. Okay, so since we have a pair of opposites like negative 6y and 6y, I can go ahead and add those down and they would eliminate each other. So all I'm doing is I'm kind of combining these equations into one by just adding them together. And generally, we set it up where we just add straight down. It's nice to have them lined up so we can add straight down. That helps us to combine like terms very easily. Okay? So 5x plus 3x is
8x.
8x. Negative 6y and 6y
0.
would be nothing, right? Gone. So we're just not going to write anything. Not even a 0. I bring down my equal sign, and negative 32 plus 48
16.
is 16.
And then do you divide or no?
Yeah, because that's what's left after we eliminate one of our variables. That's what's left. Can you solve that?
Yeah, x equals 2.
Sure hope so. Yeah, divide by 8. X equals 2. You guys are saying that's easy. Are we done?
No.
Not quite, right?
Don't you have to find y?
Every answer we found so far in systems is always an ordered pair. Okay, so we have to continue that trend. And the second half of elimination is the same way that we did the second half of substitution. So once I have one of the answers, all I need to do is just plug it back into one of my original equations to find the other answer. Okay? So, and honestly, again, like substitution, it doesn't matter. It doesn't, there's not one or the other that you have to do. Sometimes one's a little bit easier to work with than the other, but that's just your personal preference. So, that being said, which one would you guys like to substitute back into?
3x plus 6.
The bottom one? Okay, fair enough. Usually, I've noticed that a lot of students pick the one with less negatives, which makes sense to me. That's fine.
So you do 3 times 2.
So I would do 3, and then my x value is 2, plus 6y equals 48. So this is just the same way that we did the second half of substitution. So 3 times 2, and please don't do 32, right? It's not 32, it's 3 times 2. So that's 6 plus 6y equals 48. Opposite operation to keep it balanced. 6y equals 42.
7.
Divide by 6, and y is 7. So what is my answer? 2, 7. Ordered pair. 2, 7.
This is easy.
Yeah.
Good. Can I get a comfort level how you're feeling right about now? Good. Now that I see lots of 3s and 4s, let's make it harder. All right. So let's make it a little bit harder. We're not going to make it a whole lot harder today, but just a little bit harder. Okay, what's up with example 2? Do we have opposites?
No.
You might be
yes,
tempted
we
to
do.
say 5x and 5x, but what's 5x plus 5x?
10x.
10x. That doesn't eliminate. You may say, well, Ms. Craw, one's positive, one's negative. What's negative 2y plus y? Negative 1y, right? So neither one of them eliminate each other. Do you see anything that's close to eliminating each other?
No. Well,
Both of these are kind of close to eliminating each other. What is a easy way that I could make a pair of opposites here? Yeah, Ethan?
Adding equations together, you can subtract them.
Yes. And some teachers actually teach that. But I am not one of those teachers. Because I don't like that sometimes you add and sometimes you subtract. You can, but I'm not going to do it that way. Does that make sense?
Yeah.
So that's an option. I'm not going to teach you that option, but that's an option. So if you want to do it, by all means, okay? But along those same lines, how could I make this able to be eliminated? What do you think, Sarah?
You switch sides.
Switch signs? Okay, so, because if I switch signs on one of the 5x's, then I would make a negative 5x and a positive 5x, in which case I could add them and eliminate. But I don't want to just be like a math magician.
And then make
Yeah,
it 2
you get that? You get that? Not a math magician. I don't want to just like magically say, bada bing, it's negative 5y. Or sorry, negative 5x. How could I mathematically do that? How could I mathematically switch a sign? What? No, I'm not going to borrow. That would be magical. Flipping is magical. I need mathematical.
Changing all the signs.
What?
Changing all the signs.
Okay, still mathematically, how do I change all the signs? I don't want to teach you a trick. I want you to do math stuff. Yeah?
Opposite operation.
We're getting there. Yes, sir?
Multiply by -1.
Multiply by -1. That would change all the signs, right? Okay? So, and remember, anything I do to one piece in an equation, I have to do to all the pieces when I'm talking multiplication and division. So, essentially, I'm going to take one of the equations, either the top or the bottom, and I am going to multiply by a -1 on every piece. So again, Doesn't matter which one, you guys choose. Which one would you like to multiply by the negative 1?
The bottom one.
Bottom? Okay, fair enough. So I'm multiplying by a negative 1, so 5 times negative 1 makes it a negative 5x. And all I'm doing is really just switching the signs. Positive y times negative 1 is going to be negative y. Negative 9 times negative 1 is going to be a positive 9. So I changed all my signs. Now do you see a pair of opposites?
Yes.
Sure do, right? And all I'm going to do now is add down. So 5x and negative 5x.
0.
It's gone. Negative 2y and negative 1y.
3y.
Makes negative 3y. And 3 plus 9 is 12. Again, I've eliminated one of my variables. Now I'm ready to solve what's left. So divide by negative 3.
Negative 4.
Y is negative 4. Again, not done.
You gotta solve for
I need an x value to go with it. So, Hannah, would you like to use the top or the bottom? Top. Okay, top it is. So I have 5x minus 2, and my y value is what? Negative 4. That's what I just found. That is the ugliest 4 I've ever drawn in my life. Negative 4 equals, run out of room, equals 3. So I use the top equation again. If you use the bottom equation, you're not wrong. It's just a different way of coming up with the right answer. So I need to multiply, so I have 5x. Negative 2 times negative 4 is a positive 8. Subtract 8. 5x is negative 5. Divide, and x is negative 1. So then my answer,
negative 1, comma, negative 4.
good. I don't want you to fall into the trap of putting negative 4, comma, negative 1. What might make you want to do that?
Because you solved for y first.
Yeah, you did negative 4 first and then negative 1 second. So you might want to put them in the ordered pair that way. Don't fall into that trap, right? It's always x, comma, y, regardless of what you solve for first. So I have negative 1, negative 4. Alrighty. Yes, sir.
4.
Oh, you're giving me a 4. Okay, let me let you guys do some on your own, and then maybe we can revisit seeing where our comfort level is and see what kind of progress we made today, okay? So I'm going to have you guys do the 4 try these together with your partners, and then I will come back through and kind of answer questions that we have. I'll be filtering around, so make sure you ask questions if you have them, okay? All right, go ahead.
Mr. Craw, do you think I could try number 1?
I'm going to work through them. Okay, so do I have a set of opposites?
Yes.
Yes, so I'm ready to eliminate. I'm ready to add down and eliminate. So 6x and negative 6x is gone. Negative 3y plus 5y is 2y. Please don't put equals 3. I saw some people do that, and that's actually pretty common for some reason. When it's the same number over there, some people just like put it down rather than adding them together. It's a really common mistake, and I don't really know why, but it is. So 3 plus 3 is 6. Divide by 2 on both sides, and I get y is 3. Don't forget to finish the problem. Chad, would you like the top or bottom? Bottom. So I have negative 6x plus 5. And y is 3 equals 3. So I have negative 6x plus 15 equals 3. Subtract 15. Negative 6x equals negative 12. Divide, and x is negative 2. No, positive 2, sorry. So then my final answer is 2, comma 3. Questions? All right, let's go to, I'm skipping 2. I'm going to go to 3. What was the answer of 2?
Negative 1, 3.6.
Negative,
Okay.
or 1.5 times 2.
Yeah. Sure.
That was 3.
Yep. All right, 3. Okay, so 3, do I have opposites?
No.
No, so I need to make them. Okay, so I'm going to change the signs. I would actually prefer, and again, this is not necessarily you're right or wrong, but I would prefer to do the bottom.
Yep.
Because if I do the bottom, I get rid of some negatives. I don't know, that's just my personal preference. So negative 5x becomes positive. Positive 2y becomes negative. Negative 7 becomes positive. So I multiply by a negative 1 to change the signs. Now I have opposites. Now I can add down. So 3x and 5x is 8x. 2y and negative 2y is gone. Bring down my equal sign. 5 and 7 is 12. Divide by 8. Act like the world is ending because it is a decimal. Think you did everything wrong in the entire world. That's what happens when every student ever gets a decimal. They're always like, Mr. Craw, what did I do wrong? I mean, there are decimals in the world, you know.
Nobody likes them though.
It just seems wrong, Mr. Craw. It just seems like it. That's what they always say. Don't feel like you're alone because everybody in the world does. Not everybody in the world. Every student in the world does that, I feel like.
Because the way
Maybe I should just start
structure
making.
Is the way when we learn it, we learn whole numbers.
Well, maybe I should just start. Maybe I should just start making every single problem have fractions or decimals in it.
I might have your own
Okay, we'll have a decimal.
Hold on, we're getting off. We're getting off track. We're getting off track. Sorry. Okay. Shh, all right, let's keep going. So I need a y value to go with it. Sam, would you like the top or bottom? Top. Sounds good. So I have 3. My x value is 1.5 plus 2y equals 5. 3 times 1.5 is 4.5. Opposite operation. 2y equals, easy there, 0.5. Divide by 2, and y equals 0.25. So then my ordered pair is 1.5, 0.25. All right, any questions on 3? Okay, 4 is really important actually. Because it gives you a hint there. Line it up first. I don't know why the exclamation point got outside the parentheses. That's weird. All of your English teachers would shame me for that. That's okay though. So I need to line them up first. Okay. And there's no real like right or wrong way to do this, but generally when I line them up, I like to put x and y on the same side like a normal elimination problem, but really you can line them up however you want to. Do you have a question? What? Oh, okay, how did you switch them?
I just put the 7x on the same side and switched it into 3.
Okay, so you just had x on the same side and then put y and the other number on the other side? That's fine. Yeah, like I said, there's a lot of different ways. Probably none is really easier than any others, right? You're pretty much moving, I don't know. So I will do the top one in red, and I will subtract y to the other side. So I have 7x minus y equals 12. I'll do the bottom in blue, and I would subtract 7x to bring it over to the other side. And just to line things up, I'm going to put my x first, so negative 7x, my y second, negative 3y. Now I have my equal sign in the right spot, and I'm left with 8 here. So now I have them lined up. X's over X's, Y's over Y's, equal sign over equal sign. The most important thing is that whatever you're eliminating is on the same side of the equal sign. If they're on opposite sides of the equal sign, you are mis-eliminating. If that's even a word, I just made it a word. I have opposites now, so I'm ready to add down. 7x and negative 7x is gone. Negative y and negative 3y is negative 4y. 12 and 8 is 20. Divide by negative 4. Y is negative 5. And then, of course, I have to find my x. Sydney, which one do you want to use? Top? All right. And you can honestly use this equation, or this equation, or this equation, or this equation. Any of the original equations before you started eliminating, you can use any of those. So were you talking about the top?
Yeah, that's fine.
All right. So 7x, oh, need a pen, sorry. 7x equals y, which is negative 5, plus 12. What? In this case, since I'm not really multiplying, it's not a huge need for parentheses. Okay, but yes, usually when you plug them in, you should. So 7x equals 7. Divide and x is 1. So then my ordered pair 1, comma, negative 5.